This is the GitHub for my project for embedded systems. I'm going to start by going through the GitHub, highlighting the code I developed and any significant bits. And at the end of the video, there will be a recording of an oscilloscope showing how this code works and filters. So we start with the circuit diagram. It's quite clean. There's just a messy input and clean output, as well as a potentiometer used to calculate the phase shift. I used MATLAB to create a filter, as well as creating a sine wave lookup table. The sine wave lookup table was an important part of this code, as it helped optimize. Instead of using a sine function, I was able to just use the lookup table and saved a lot of time rather than using the Taylor series to create a sine wave. Systic was used within this code. This was used to keep track of time as well as keep consistent sampling rates for the read ADC and the write DAC. There was an error within the ADC code. This caused a drastic delay due to this one line. This one line had a delay set to, as we see here, 0.0f, and it caused a drastic delay of about 80 microseconds compared to when this was reduced to about 30 microseconds. And with further reductions down to 1, there was very little improvement seen, so it was kept at 0.07. This did not make a difference to the code, but allowed the code to be more stable as the ADC had more time in between taking samples to stabilize. This was an important part of the code as we were having errors while coding it up, which would lead to samples not being able to be processed in time and delays occurring and the buffer overfilling. The main code had 3 main parts. So this was where the samples were gotten from a buffer and filtered and then used to be able to calculate the frequency, the max and mins of a signal put in. There was also the frequency averager, which got the average frequency over time, which allowed for less fluctuations, as well as a phase shift function, which allowed us to calculate the phase shift to go into a sine wave to be able to adjust its phase. It's just a little more detail here on how the averager worked. So there was 2 ways of doing this. There was the weighted average, which is commented out but would work just as well, or brute forced average, which is done by code, taking 40 samples and averaging it over time. There was the phase shift. This was read in using a different ADC channel and converted the units taken from that ADC into a negative pi or a positive pi, and that scaling allowed for around 180 to minus 180 degrees phase shift. There was then the filter applied. This was a low pass filter, allowing low signals through and removing the high frequency signals. This was a simple filter implementation, again taken from the MATLAB equations with the B and A coefficients gotten there. Then we had the sinusoid generator. So initially the sinusoid generator was quite simple. The scale and offset was gotten from the max and min, and the phase was calculated using the frequency and time and phase shifts. These are the normal equations used for a sine wave, and then they were used to calculate the sine wave in terms of units of offset and scale. This was quite computationally extreme, so there had to be a faster way of doing it. I had to find a way of doing this. The way this was done was the lookup table shown earlier, gotten from MATLAB. This lookup table helped truncate the values. So instead of having infinite values, there was only 256 values. And there was also an issue of when the frequency changed at the max value, that there would be drastic changes as the phase would shift. So having a phase accumulation led to this actually being reduced, and you could no longer see drastic frequency adjustments at one single maximum. There's also buffers used, so the code here just goes through how the buffers are implemented and how things are put in and taken out. Conclusion, and the results for low frequencies, high frequencies, and expected frequencies. An expected frequency is 50 Hz based on the Irish power grid system. and then some future works that can be implemented.